So today we are going to evaluate this integral sine squared t over t square. And this integral is quite important, especially to chemistry students, because they encounter this integral in what is known as time-dependent quantum mechanics while deriving the transition probability between two quantum states and eventually get what is known as Fermi's golden rule. So this is part of any quantum chemistry course or any spectroscopy course in chemistry. So before we integrate and find what is the value, let us plot this integrand, the function I'm going to integrate, sine squared t over t squared. Now remember, this t is just like a dummy variable. I can put x, y, z, anything there. So this sine squared t over t squared would look like this, the curve shown in red. It oscillates and then eventually it becomes 0 for large value of t. Now what happens when you integrate this function? Before we do this, let us also analyze this function more closely. From the plot, it is obvious, and also from the expression, that this is a symmetric function. Symmetric around 0, because if we change t to minus t, the whole function doesn't change sign. Sine squared t over t squared doesn't change sign. So integration of this whole function from minus to plus infinity just twice that of from 0 to infinity. So this is exactly what we are written here. If you integrate from 0 to infinity, it is just half of integrating the same function from minus to plus. And if you integrate this is we're going to prove in few minutes. This is what you see. The result is well known. It is pi. Now let us look at a different function, which is sine t over t. This function also has the same property. It is symmetric around 0 because we change t to minus t. Sine of minus t becomes minus sine t. T becomes minus t. These two minus signs will cancel each other. So the function is actually symmetric around. Now, if you integrate this function, you'll get same result. You'll get result which is equal to pi. So both the functions are different. When you integrate from minus to plus infinity, you get the same result, pi. To plot them together, they look something like this. So we'll illustrate sine squared t over t square integrated from minus to plus infinity is equal to pi, as well as we'll illustrate that sine t over t when integrate from minus to plus infinity is also pi. So let us proceed. So let us define this integral from 0 to infinity of this function sine squared t over t square as j, as shown here. And now you proceed by doing what is known as integration by parts. And this is a formula for integration by parts. I think all of you know. Integral of u dv is uv minus integral of v du. And if you assume that u is sine squared t, then du is 2 sine t cosine t dt, which is nothing but sine 2t dt, because 2 sine t cos t is sine 2t. Similarly, if you take dv to be tt over t square, your v becomes minus 1 over t. And then you make use of the formula, then the integral j becomes minus sine squared over t from 0 to infinity plus this integral. So let us look at this term carefully. The first term actually is 0 because at two limits, when t goes to 0 or infinity, the function becomes 0. Why? Because sine squared t varies from 0 to 1, and 1 over t becomes 0 when you go to very large value of t. T goes to infinity, it is 0. And also on the other side, sine t becomes 0 when t is 0. So you have this integral, sine 2t by t, integrate from 0 to infinity, which you can write as sine 2t over 2t times 2 dt, which is nothing but something like sine z over z, where z or z is nothing but 2 times t. And this integral is half of the whole integral. So eventually, see that this integral is pi by 2. So I'm just writing it down here, it's pi by 2, because you know this 0 to infinity is just exactly same as 0 to infinity for sine t over t and sine squared t over t squared. Okay. I'm going to show it. So, okay, now let us do this. So let us evaluate this integral. This is the most important integral. So if you know this integral, then we know what is the value of the integral sine squared t over t square, because you know that one integral is connected to the other integral. Because we have just shown that sine square t over t square integrated over dt is nothing but sine t over t integrated over dt. They are the same. Because this is exactly what I did. We showed that j is nothing but sine t over t. So t is just a dummy variable. Okay. So let us do it. So let us define this as j1, and then I define something like f of s. S is some parameter. Just look at carefully what we have done. We have multiplied the integrand with exponential minus st. So the whole thing is actually a function of this parameter s. And if I put s equal to 0, you get back your old integral. This is exactly what we want to evaluate. Take a derivative of this function f with respect to s, which I'm calling f prime s, is going to be like this, because the integration is from 0 to infinity. So the differentiation will go inside the integral. And if you differentiate exponential of minus st with respect to s, this minus t will come down. So this t and this t will cancel. You'll pick one minus sign. So you're getting minus of integral 0 to infinity of exponential of minus st times sine t, as shown here. Now again, we do this integration by parts. You know the formula. We make these substitutions, u as exponential of minus st and dv as sine t dt. If you make these substitutions, then my integral becomes like this. You have this surface term, then minus this integral. Now carefully look at this term. This term at the boundaries, see what happens to this term. When t goes to it's a very large infinity, this exponential minus infinity, which is 0. When t goes to 0, cosine 0 is 1. So it is actually 0 minus 1. If a minus sign here, you have to take care of all the signs very carefully. And you will see that what you get this f prime s is minus 1 plus s times this integral. Again, we use integration by parts. We make this substitution from here. U as exponential minus st. So du just minus s exponential of minus st dt, and dv is cosine t dt. So that v is sine t. If you make this transformation, it is not very difficult to do. It can be shown that eventually f prime s would become something like minus 1 plus s. And again, the surface term in this case, since it is a sine t times exponential of minus st, is 0. And eventually you have this expression for f prime s. So f prime s is minus 1 times minus a square f prime s. Remember that f prime s is nothing but this integral, which we have defined just a few minutes back. So when you do the algebra, your f prime s becomes minus 1 over 1 plus s squared. And you can integrate this because this is a standard integral. When you integrate, you get minus, have this minus sign, then tan inverse s or arctan plus a constant c. Just look at what happens when s is very large. When s is very large, your exponential term will become 0. So f of infinity is actually 0 because this term will become very, very large. S is very large, s goes to infinity. So, but what happens to tan inverse of s when s goes to infinity? This is pi by 2 because we know, because if you plot tan inverse, say s as a function of s for plus minus infinity, it will saturate to a value which is nothing but pi by 2. So this will give you the value of that constant c, because what you have here is 0, which is equal to minus tan inverse of infinity, which is minus pi by 2 plus c. So you can take pi by 2 on the other side. So c becomes pi by 2. So this is my result. If s is minus tan inverse s plus pi by 2. And let us check what happens when s is 0. When s is 0, tan inverse 0, I know this is 0. And so f of 0 is nothing but pi by 2. But what is f of 0? Recall, f of 0 is your integral j1. This is the integral j1. Integration of sine t over t from 0 to infinity. Okay, and this is pi by 2, which you have shown. And you recall this, that if you integrate from 0 to infinity, it is just half of integrating from minus to plus infinity for sine t. And this is also true for sine square t, okay? And sine square t and sine square t by t square and sine t by t, these two integration are related by this identity. They are identical because if you integrate, you get pi by 2. So eventually, I have the result for integration sine square t over t square, which is nothing but pi if you integrate from minus to plus. So what did you do? We started from sine square t over t square. We first integrated this using what is known as integration by parts. And eventually, you showed that the sine square t by t square integration is equal to the integration of sine t over t. And here, then we found the value of sine t over t, which is equal to pi by 2, which is from 0 to infinity, pi, which is from minus to plus infinity. So eventually, the integral sine square t over t square integrate from minus to plus infinity is nothing but pi. Thank you very much for watching.